Hey Geometry, this is Chapter 4, Section 2, Classifying Triangles. Pause the video, try the warm-up, come back and check. Okay, so as you know, this angle 1 is a right angle. Angle 2, acute. And what do we call this? Obtuse. If the perimeter here is 47, then you know what we need to do with these sides. That's right, we add them up and set it equal to 47, solve for x, and you should have had x equals 5. So the lengths are 8, 16, and 23. Remember to include a complete answer. Not just that x equals 5, but 8, 16, and 23. So today the objective is to classify triangles by their angle measures and classify by their side lengths. We will use triangle classification to find angle measures and side lengths. So we know what a triangle is, right? A polygon with 3 sides. Polygon, again, is a closed figure with segments for sides, right? Triangles may be classified 2 ways, by their angle measures and by their side lengths. So we have a box of triangle classification by angle measures. So if we have 3 acute angles in a given triangle, we can classify it as a acute triangle, right? If it has 1 right angle, we would call it a right triangle. What if it has 3 acute angles and the acute angles are congruent? We call that we're basing this on angle, so be careful how you phrase this. It is called an equiangular triangle. And yes, when we have an equiangular triangle, we have an equilateral triangle too. Remember, these little arches tell you that these angles are congruent. The arch is the same in each case, right? And if you have a triangle where there is 1 obtuse angle, it is an obtuse triangle. All right, we are to classify triangle BDC by its angle measures. So remember that you can take your eraser or your pencil and trace over the triangle that we're being asked to classify. It isn't the largest triangle in this figure, it's BDC. So we want to analyze the angles, right, and see what kind of triangle is this. I see a 10-degree angle here, right? And then we see a 100-degree angle here. And so this angle over here must be 180, take away these 2, right? And so it is an acute angle over here. But due to this angle B being 100, we can say this is what type of triangle? That's right, an obtuse triangle. Let's classify ABD by its angle measures. Well, we see that this angle is 80 degrees. We could call that angle B in this little triangle. And this little angle over here, the D angle, is 20. So 80 plus 20 is 100. So angle A must be 80 as well, huh? 180 would give us the angle that would sum this entire set of angles to 180. So all of these angles are less than 90, so we would say this triangle ABD is acute. If we classify triangles by side lengths, we have some different names. When we have 3 congruent sides, as I said earlier, this is an equilateral triangle. When at least 2 sides are congruent, we call it isosceles. And finally, if there are no congruent sides, it is known as a scalene triangle. Remember, when you look at a figure, you cannot assume segments are congruent based on appearance. They must be what? They must be labeled, right, or marked as congruent. Classify triangle EHF by side lengths. EHF. Well, that little red dash tells us that length EF is congruent to length FH. So FH must have a length of 10 like this side does, right? And so this triangle has two sides of the same length, so we call it isosceles. How about if we classify EHG? EHG, pause, take a moment, classify it by its side lengths. Well, EH is 12, HG is 11, and the length of EG is 14. No side is congruent to another in that triangle, so we would call this triangle scalene. Now let's find a side length. This is triangle JKL. Let us find the value of X in order to find the side lengths. So first we know that JK is congruent to KL. That was given by these marks, right? So we can take this expression, 4x minus 10.7. Well, I guess we'll have to say that their measures are equal, right? And so we can take those two expressions and set them equal, and we can solve for x. And go ahead and pause and do that, come back and check. And we find that x equals 8.5, right? And so now that we know that x is 8.5, we can use substitution to find the actual lengths of each side. So plug those in, and you should have JK equals 23.3. KL is also, of course, 23.3. And JL is 44.5. In this next sample, we have an equilateral triangle. And so we know that all sides are congruent, right? That's given by the equilateral triangle up here. So we can say that the measure of those sides must be equal. That's the definition of congruent segments. So we're ready now to substitute, right? And so we can choose any two sides expressions to substitute and solve for y. And then we'll find the side lengths. So subtract your 2y, add your 4, and you have y equals 7, right? And so now that we have y equals 7, go ahead and find the side lengths. Come back and check your work. Well, all we have to do really is substitute that known value into one expression, like FG, and when we do, we find the side length equals 17. And then you would know, of course, that each side is a length of 17. We now have a little series of real-world questions involving triangles that you can try and answer, and then come back and check your work. A steel mill produces roof supports by welding pieces of steel beams into equilateral triangles. Each side of the triangle is 18 feet long. So how many triangles can be formed from 420 feet of steel beam? All right, so if each side of the triangle is 18 feet long, then how much steel would be needed to form a single triangle, right? That would be 18 times 3, right? And that is 54 feet. So if we have 420 feet of steel beam, we can simply divide that by 54 feet per triangle, right? And find the number of triangles. And so we have 7 and 7/9 triangles. 7/9 doesn't give us enough steel to complete an 8th triangle, so we would say that the steel mill can make 7 triangles from 420 feet of steel beam. This is somewhat like the last one. Each measure is the side length of an equilateral triangle. Determine how many 10-inch triangles can be formed from a 100-inch piece of steel. So again, one triangle, being equilateral, would require 3 pieces of 10-inch steel. So that would be, what, 30 inches per triangle. And now if I have 100 inches to use, I could simply divide 100 by 10, and I can make 10 triangles from a 100-inch piece of steel. All right, try the lesson quiz. and then come back when you're ready to check your work. Classify by both angles and sides. MNQ is if we classify, let's do the angles first. Equiangular and equilateral. And it's also acute, right? Angles and sides. Okay, they're being more general when they say acute. It is not given that it's equiangular, but when you have an equilateral triangle, you have equiangular triangle as well. NQP is, if it's not acute, it's obtuse, right? Each side is different, so it's scalene. MNP is acute and scalene again. Let's find the lengths of this triangle. Look at, we've got isosceles, so these two expressions are equal. That helped you find x, right? And the side lengths then are 29, 29, and 23. There you go. Have a good time. Enjoy your triangles today.